Alrighty, so we're going to do some proofs involving triangles now. And these are two-column proofs. Now, the course does state that you don't have to use two-column proofs. You can explain things in a paragraph instead. Most of my students that I've had experience with in this course prefer the two-column proofs to writing it all out in paragraph form. So it's up to you, but the two-column proof is usually a bit easier for most students. But if you don't want to do that, you can go ahead. Just make sure you explain all the logical connections in a paragraph, okay? So we're going to do some examples of proving triangle congruency, and then we're going to do some other proofs with triangles. So if we're going to prove triangle congruency, we have to go for one of those three things that we've seen already. We have to show that we have a side angle side, an angle side angle, making sure that the thing in the middle here refers to an included side or angle. Or if you can show that all three sides are congruent, you're also in business. Okay? Sometimes you have to be a bit clever with these. So let's see what's going on. So first of all, we want to prove that these triangles are congruent. I'm going to make note that I have two sides here that are congruent already. So with those two sides are congruent, I'm going to make a statement about that. We'll say that side AC is congruent to side CE. They told us that. And if it's something they told you, you can just say given. So that's a given. All right. Now what we're going to do is we got to find another way to do it. Now be careful, these little arrow things don't mean that the sides are congruent necessarily. What they mean is that they're parallel. So if those lines are parallel, I want to show you a little trick here. If we extend those lines out, or extend most of the lines at the ends here, all of those, what we notice is we've got some transversals happening. So we can see that AE is actually a transversal of both this AB line and the CD line. And AE is also a transversal of the DE line and the BC line. And since those lines are parallel, that'll give us some information about the angles. And the first thing I want you to notice is that this angle and this angle have to be equal. And those angles have to be the same because of the transversal property. So we're going to say that angle BAC has to be congruent to angle DCE. And those two angles have to be congruent because they are corresponding on a parallel transversal. And that's something that we already know about. Okay, so we've got those two being the same. Then we could also say that this angle down yonder and this one up here have to be the same. And so they would be angles, let's see, BCA from the top one. Angle BCA has to be congruent to angle DEC. And that's for the same reason, because those are corresponding angles on a parallel transversal. Okay, so we've got that established. And now what you'll notice is that we have corresponding pairs of angles, included sides, and then the third angle, and that gives us ASA. So now that we have ASA, we can say that triangle ABC is indeed congruent to triangle CDE. And that's because we have angle side angle pattern. And we are done. QED, quod erat demonstrandum. Okay? So that's how we prove that things are congruent. We sort of work our way toward establishing one of these three patterns. And then once we've got that, we've proven that the triangles are congruent. Okay, so what if I have to prove something else about some triangles? So for instance, in this case, I have to prove that in is congruent to an. All right, so basically I want to show that this side and this side are congruent. Well, the way that we do that is we sort of state all of our givens, and often if I'm just trying to prove that two components of two different triangles are the same, all we have to do is show that the triangles themselves are congruent, and that means that those two things will be as well. And we'll talk about how that all fits together here. So let's make a note that all the things that we know are congruent from our diagram. I know that angle ICN is congruent to angle ATN. Okay, and that was a given. Let's write down the other givens we have here. Angle tan, TAN, is going to be congruent to angle CIN. Okay, and that's also given. They told us that in the diagram, that those two things are the same. All right, so we've got two congruent angles and the side in between them there. So that included side, CI, is also congruent to side AT, OTA, whichever way you want to say it. So if those two things are congruent, also given, then what we have here is an angle-side angle pattern. Same one that we ended up using last time. So now we can say that our triangles are congruent. So triangle CIN is congruent to triangle, and this is the big conclusion that's going to help us with this, triangle tan, and that is by the angle-side angle pattern. And once we have that, then we can conclude that in is congruent to an, because these two lines here are actually, they're just corresponding sides on triangles that we already know are congruent. So therefore those corresponding sides have to be congruent. And you can write out corresponding sides or whatever, but usually you'll see folks in two-column proofs, they'll write CPCT, which means corresponding parts of congruent triangles. Okay? You don't have to write that out, and you don't have to write CPCT. Whatever way you want to say it is fine, as long as it's a good justification. Okay, and that's it. We've shown what we were required to show, so QED, and we're off to the races. Okay, so when you're proving that two triangles are congruent, you have to show side, 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 or side, angle, side, or angle, side, angle. The pairs of angles you will need to prove congruent triangles depends on the information that's given. Okay, the pairs of sides and angles that you need. So whether you're using ASA, side, angle, side, or side, 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 it just depends on what you have. You sometimes have to play around with it a little bit until you can get it to work out. And to prove that components of triangles are congruent, so to prove that components of triangles are congruent, it's often necessary just to show that the triangles themselves are congruent. And then it gives it to you. All right.